Welcome back to this course on blockchain and its application. So, till now you got a kind of broad idea about what blockchain is, and then Professor Shural has discussed about certain fundamental idea behind cryptocurrency, the cryptographic techniques and digital signature which are used in the design of blockchain. So, we are going to see that how these different techniques actually used or they form a basic structure of blockchain. Before going to that, we are also going to talk about, particularly in this lecture as well as a couple of subsequent lectures, a kind of broad history about blockchain, that how this concept of blockchain got evolved and where we stand today in terms of different techniques that we use in blockchain. So, interestingly, although this concept of blockchain got very popular around 2014, 2015, around that time, but it is not like that the concept have been invented around that time in around that instance. Rather, this concept of blockchain or the fundamental techniques that are used in blockchain, they are pretty old. They are dated back in 1970s and 1980s, when people have started thinking about the distributed systems and the architecture for a distributed system. And blockchain actually, the idea of blockchain actually borrows concept from different areas, different domains, where they apply these concepts together and form up an interesting technology that can solve multiple different problems. So, in today's lecture as well as in the few other subsequent lectures, we are going to talk about or going to have a journey on this history of blockchain and try to understand how blockchain integrates different concepts from different domain and build up a kind of common platform or common technology place that can be utilized for different other applications. So, these are the topics that we are going to cover in today's lecture. We are going to talk briefly about the nature of distributed systems and the idea of distributed systems that are borrowed in blockchain. Then we will try to see that blockchain as a distributed system, how this blockchain borrows the concept from distributed system and build up an architecture out of it. And then we are going to look into one of the particular property or a particular algorithmic space in distributed system, which is called distributed consensus, which is very much relevant in the design of blockchain, and we are going to have a journey in its history, that how the literature of distributed system have evolved over time. So, these are the kind of keywords that we are going to talk about in today's lecture. Well, so we are broadly touching upon distributed system and the consensus protocols in distributed system. So, the three important pillars that are there behind the design of blockchain architecture are: first, the distributed system; the second, different cryptographic techniques; and the third one is different kind of economic models that have been utilized in the design of blockchain, well, which are particularly being very useful in the context of cryptocurrencies. So, the cryptographic techniques which are actually utilized for blockchain that Professor Shural has already covered, we are going to look into their applications in the context of blockchain. But today I am mostly going to touch upon these distributed system concepts, which are very useful in the design of a blockchain. So, this is one of our core problem whenever we are talking about blockchain. So, what I have mentioned earlier, that in case of blockchain, I have a data structure, basically I have a chain of blocks that is maintained in all the individual nodes. Well, so that means every node maintain their local copy of blockchain. Well, now say one particular node, here node 6, it adds up a new block in the blockchain. Well, so now when node 6 adds up this new block in the blockchain, at that time I need to ensure that all other nodes in the network, they need to agree on this new block. Well, so they need to agree on this new block and they need to add this block to their copy of the blockchain. Well, so this is the kind of problem that I have to solve while I am going to design blockchain. Now, interestingly, this particular problem is not a very new problem in the context of blockchain, rather it is a very old problem in the distributed system literature, and this particular problem where someone is proposing something and all other neighbors or all other peers have to collectively decide on whether to agree on that proposal or not. This particular problem is termed as the distributed consensus problem. Well, so this distributed consensus problem is a classical problem in the distributed system literature. There are a lot of different variants of this problem, and we are going to see that how this problem is actually relevant in the context of blockchain. Well, because here you remember that what I need to do, someone or one of the nodes have proposed a new block. So, I need to ensure that all other nodes in the network, well, or all other peers in the network, they have to agree on that particular block. Well, now just one thing, that who are these peers? These peers are nothing but the different organizations who are participating in the blockchain network. Well, so if you remember the initial examples that I have talked about in the context of petroleum supply chain management. So, in that case, that every node is either a distributor or a retailer or a refinery, well, or a crude producer, they can be anything. Well, so all these nodes who are participating in this blockchain network and who want to come to have a kind of common business goal. Well, so now one of them produces a new block. Well, so for example, one of the refinery, they actually produces a new block stating the information that the amount of different products that they have produced on that day. Well, and how much different crude oil or what amount of crude oil they have used to produce those individual products. So, that way they form a block which contains that information, and now other nodes in the network, so other players in the network, they need to agree on this block. They need to ensure that this block is a valid block, a correct block, this is coming from a correct participant in the blockchain, and that way they will be appending this particular block in their local copy of the blockchain. Well, so once this consensus procedure is over, then we are going to give guarantee that everyone in the blockchain, they have the same copy of the database. Well, so they have the same copy of the information. So, everyone is in the same page. So, let us see that how we can ensure that. So, here is the typical model for distributed consensus. Well, so let me explain it with the help of an example. So, assume that you and 3 of your friends, 4 of you, after this class you want to go to either in a burger shop or in a pizza shop to have certain food. Well, so you want to have either burger or pizza, but whatever you want to do it collectively, right. So, all 4 of you want to go together. Well, but because say assume that during this pandemic scenario, you are at your home, you are attending the class from your home, and you actually need to decide it. Well, so one way of deciding it, that someone of you becomes a leader, that means that person makes a call to everyone, gets their choice, and after they are getting their choice, then that person decide where to go and again informing that choice to other. Well, so again what you are doing here, you are relying on one of your friend. Well, you are relying that the friend who is doing that coordination, giving a phone call to everyone, that friend is actually a kind of good friend. That person will not make any kind of false claims. Say for example, although 3 of your friends is planning to go for a pizza, but that friend like burger, he can tell to others that, well, everyone has agreed on burger, let us go for burger. So, this kind of fraudulent behavior that person will not do. Well, so what you have to do, you have to trust that person, but as I have mentioned that whenever we are discussing something around blockchain, we do not want to trust anyone. Well, we want to have a kind of complete trustless setup. Now, if I want to have a kind of complete trustless setup, then the question comes that how can we reach to a consensus in this context? Well, now to reach to a consensus in this context, what we can possibly do that, well, everyone has their own choice, someone likes burger, someone likes pizza, and we need to collectively decide that what to do. So, what happens that say everyone they makes a call to others. Well, so you make a call to all of your 3 friends and say that, hey, I like burger. Well, similarly, another friend she make a call to others and tell that, hey, I like pizza. Well, so that way everyone calls each other and everyone tells his or her choice. Now, that way everyone will get the information from others, right. So, you can find out that, well, your friend X what he prefers, Y what she prefers, Z what she prefers, and so on. That way you have a you will have a kind of collection of items, collection of choices, and everyone can find out from there that what is the kind of majority, whether the majority is going for or looking for burger or majority is going for pizza. Accordingly, you can decide that, well, let us go for burger or let us go for pizza. Well, so this way in a distributed setup you can actually do that, and you can decide that, well, what to do. So, this particular problem and the corresponding solution, this is called a distributed consensus problem. So, every one of you collectively coming to a consensus. Well, and here you see you do not need any leader, you do not need any friend who is working like a leader who need to make a phone call to others, rather you working in a complete distributed way, and that way you are every one of you are getting the choices of others, and accordingly you are locally deciding that what to do, whether go for a burger or whether to go for a pizza. So, so that way you can always take a majority voting and decide. Well, so you can think of that, oh, my life is good, I can just make a phone call to all my friends and find it out. So, the first thing that I would like to mention here, that as I always like to discuss about all these different trade off that I have in different solutions. So, here you can see an interesting trade off between the centralized solution and the corresponding distributed solution. So, in case of a centralized solution, you see that you have to possibly make less number of phone calls. Well, so for example, if one of your friend say she is working like a leader and she tries to make a phone call, then she need to possibly make 6 phone calls. Well, first make a call to 3 of your friend, get individual choice, then decide that what is going to be the majority, then make 3 other calls to just inform that what is the final decision. Well, but if you want to go for a distributed way, just think of that how many different phone calls you need to make. So, here first of all everyone has to first make 3 phone calls. Well, so I have 4 persons, so I need to have at least 4 into 3, 12 different phone calls. So, after 12 different phone calls you make a decision. So, whereas in centralized case you can just make 6 phone calls, 3 to get the information and then 3 to informing the information to others to do it. So, that way whenever you are moving from a centralized architecture to a decentralized architecture, or rather from a central architecture to a distributed architecture, you are doubling up the number of phone calls that need to be done. Well, so this is the kind of trade off. Well, although I have mentioned it, but it is not like that always you need to think of that I need to make multiple different phone calls, but there are applications when these multiple different phone calls or more number of phone calls might be useful. Say for example, when you do not trust any of your friends, so you do not believe anyone, you may think of that, well, your friends may just try to impose their choice on others and you do not want that. In that case, such kind of distributed protocol works best. But well, this way you can take the phone calls, and by doing these phone calls you can think of that, well, I can reach in a consensus and I can take the majority voting and I can nicely decide that where to go. Well, but our life is not this much simple. Well, so what might happen that one of your friend, whenever he is calling to the ladies, he says that, well, I want to have a pizza. Well, but whenever that person, the same person is making a phone call to the boy, the person is saying that, hey, I do not want a pizza, I want a burger. Well, so that way you see that, well, although I might like pizza or I might like burger, but whatever I like, I am not going to say it uniformly to others. Well, I am going to send or I am going to say something to some of my friends and something different to my other friends. Well, that might also happen, because again remember that you do not trust your friend. So, even in a centralized architecture, whenever you are assuming that your friends can do fraudulent behavior, they can try to impose their own choice, the same thing might happen here. Well, so your friend may just inform to the ladies that I want a pizza and to the boy that I want a burger. Well, so that way the life might become challenging. So, if that is the case, then what you are going to do? So, this is again a kind of classical problem in distributed consensus, and this particular behavior we call it as the Byzantine behavior in the context of distributed system, and later on we are going to have a details about this kind of Byzantine behavior, and we will see that how we can design consensus algorithms in the presence of Byzantine behavior. Well, but today just try to get a highlight about how the literature of this distributed consensus has evolved over time. So, this idea of distributed consensus, it mostly started in 1980s. So, around 1985 there was a very popular theorem that got published by Fisher, Lynch and Patterson, which is called the FLP impossibility theorem, which is a very fundamental theorem in distributed system. So, this FLP comes from the first letter of the names of the three inventors, Fisher, Lynch and Patterson. So, the FLP impossibility theorem says that consensus is impossible in a fully asynchronous system even with a single crash fault. Well, now the question comes that what is an asynchronous system? Well, now broadly the communication channel, say whenever you are making a phone call, basically you are making certain kind of communication. Well, so this kind of communication channel we can broadly divide it into two groups. One we call as the asynchronous communication channel, and the second one we call it as the synchronous communication channel. Now, what is synchronous communication channel? In case of synchronous communication channel, your messages are received in real time. What is mean by real time? Real time basically means that whenever you are going to send the message, the other person is going to get it. So, you can just take an example of a phone call. Okay. So, in case of a phone call, whenever you are ringing, if that person is picking up the phone call, immediately you can say that, hey, I want a pizza, or hey, I want a burger. Well, and immediately the information gets delivered. Well, so this is what we call as a synchronous system. But on the other hand, asynchronous system means there is no bound on message delay. So, that means whenever you are going to send a message, you do not know when that message will get delivered. Well, so you can take an example of an SMS. So, in case of SMS, you have delivered that SMS, but as you know, many of the time it might happen that the SMS got lost, or SMS might get delivered later on because of certain kind of network problem and so on. Well, you have sent the SMS today and it get delivered tomorrow. That can also happen, and we have experience of such kind of things. I guess many of you also have. So, that way, that kind of communication channel we call it as the asynchronous communication channel, and you will see that our practical communication channels particularly over the internet, it is more biased towards the asynchronous mode of communication. Because whenever you are sending certain kind of data packet over the internet, you cannot give a reliable bound that well within this amount of time it is guaranteed that the message will be delivered. Because there can be problem in the network, there can be delay in the network, it might happen that the message that you have transmitted, the message gets dropped and so on. Well, so that way most of our realistic communication channels or the communication environments are mostly asynchronous. Well, now what this FLP impossibilities theorem says that well in a fully asynchronous system, that means when you do not have any kind of bound on the message delay, in that case it is impossible to reach consensus even with a single crash fault. What is a crash fault? So, typically whenever there is certain kind of failures in a distributed system, we model the failures in two different ways, broadly in two different ways. One is the crash fault. Crash fault means that there is certain kind of hardware or the software fault. That means the node has started or node has stopped responding. Well, so for example, you are trying to make a phone call to your phone friend, and somehow the phone does not have any kind of internet connectivity, or somehow the phone got crashed, well, and you are not been able to make a call. So, that we call as the kind of crash fault. And the second type of fault that we say as the Byzantine fault. So, the Byzantine fault example I have just mentioned it to you. So, you are able to communicate, but you are going to communicate with a Byzantine node who is saying different information to different person. Well, so that way we consider broadly these two different type of faults. So, crash faults are typically much more easier to handle because you are not getting any information, but Byzantine fault are more difficult to handle because there you are getting information, but you are getting wrong information. Well, so the FLP impossibility theorem says that consensus is impossible even there is a single crash fault, well, over a fully asynchronous system. Now, what does it mean that consensus is impossible? So, typically whenever we talk about distributed consensus, we talk about two properties of the consensus. One is called safety and the second one is called liveness. So, what is mean by safety? Safety basically means that the correct processes will yield the correct output. Well, so that means out of all the nodes which are there or all the processes which are there, the correct processes, that means they are neither crash faulty or not Byzantine faulty, they will always yield the correct output. Well, and the liveness property says that this output will be produced within a finite amount of time. That means there is a eventual termination of your consensus algorithm. So, if you run the consensus algorithm, you know that by this amount of time I am going to get the data. So, what FLP impossibility theorem says that it is impossible to support safety and liveness together. So, you can immediately ask me the question, then what is the point of discussion? Well, the FLP impossibility theorem says that it is impossible to reach consensus. But then what people have tried upon, people have thought of that well, let us give more priority to one property over another and try to see if I can reach consensus. So, what they have done? They have given more priority to safety over liveness, well, in the classical distributed system literature. So, safety is given more priority over liveness. Well, so safety has more priority over liveness. Now, if you just think of it and if you accordingly try to design your consensus protocol, then people have tried to show that well, I can achieve consensus. So, this FLP impossibility theorem actually given the idea to the researcher that do not think of supporting safety and liveness altogether. Either you give priority to safety or you give priority to liveness. Well, and initially people had given priority to safety in the distributed consensus literature. So, with this in 1989 Leslie Lamport, one of the pioneer researchers in distributed system who got the Turing Award because of his contribution in distributed systems. So, Lamport started talking about one algorithm called Paxos. Well, So, this Paxos, as I have mentioned, that the FLP impossibility says that safety and liveness cannot be supported together. So, the Paxos gives priority over safety. So, it supports safety, but not liveness. Well, interestingly, this is actually one of the very interesting case where Lamport had a very hard time in convincing people that hey, Paxos actually works. So, in 1989 he proposed Paxos, and around the entire 1990s people are very much confused about the correctness of Paxos, and everyone started believing that Paxos is not going to work. Well, and finally in 1998, so it is almost after 10 years, people got convinced that well, this algorithm is going to work, and this Paxos, it got published in one of the ACM transactions in a journal, ACM Transactions on Computer Systems. Well, so this can be an example for you that well, something that is very fundamental in the behind the design of distributed system, that idea people didn't accept it for around 10 years. Well, so Lamport has to fight for around 10 years to get that particular idea published. Well, so around 2001, this FLP impossibility paper that wins the Dijkstra prize, and around that time people started talking about distributed systems. So, once people got convinced about the correctness of Paxos and they started thinking about that, well, that means the distributed system can really provide benefit and it is possible to have a distributed system. So, people started talking about that, and around 2009 this concept of Zookeeper that got released, which is one of the finest distributed systems. It provides a service for managing different kind of distributed applications. Now, in 2010 onwards, there was different types of consensus algorithm that got released, including multi-Paxos, Raft, Byzantine fault tolerance algorithm, PBFT and so on. So, later on while we will discuss about the consensus algorithm, we will try to understand some of these algorithms. Specifically, we are going to learn about Paxos and PBFT in details, and we will see that how they actually work over a distributed system. So, that way today I just tried to give you an idea about what distributed consensus means and how the idea of consensus got evolved over time, and in the same way I tried to give you an example that why blockchain needs something like a distributed consensus. Say, as we have seen that whenever a new block is getting proposed for a blockchain, that new block need to be agreed by other peers in the blockchain network. That way you need to run some kind of distributed consensus algorithm, and we see that there is a vast literature on distributed consensus. Well, so there are multiple different algorithms, but the important question comes here that can we use those algorithms for blockchain? Well, so this is actually a pretty interesting question, and in the next class we are going to find out the answer of this question. So, that is all about today's class. Thanks for attending the class. See you in the next class. Take care. Bye bye.